Your brain can store roughly 2.5 petabytes of information. That's enough to record 3 million hours of television. It can remember a face you saw for 2 seconds in a crowded airport 11 years ago. It can replay the exact smell of your grandmother's kitchen, but it cannot remember a single moment from the most important years of your life. You learned to walk. You learned to speak. You formed your first bonds with the humans who would shape your entire personality, and you remember absolutely none of it. This isn't just you. It's everyone. Every human who has ever lived experienced the same blackout. The first 2 to 3 years of life, gone. For most people, their earliest memory starts around age 2.5, not 3 or 3.5 like scientists used to think. Recent research shows we actually misdate our own memories, pushing them forward in time through a phenomenon called telescoping. But here's what makes this strange. It's not that nothing was happening. Those first years are arguably the most intense learning period in human history. You went from not knowing what a hand was to using one, from not understanding language to speaking it. Your brain was doing more work than it would ever do again. So why is there nothing to show for it? The answer most people assume, that babies just can't make memories, turns out to be completely wrong. Babies can make memories. The problem is something far more unsettling. Your brain wasn't failing to record, it was destroying the recordings. In the 1980s, a psychologist named Rovee-Collier ran one of the most elegant experiments in developmental science. She tied a ribbon from a baby's ankle to an overhead mobile. When the baby kicked, the mobile spun. Within minutes, babies as young as 2 months old figured it out. They kicked faster, they kicked harder, they learned. And here's the part that changed everything. When she brought them back days later, sometimes weeks later, they remembered. They saw the mobile and immediately started kicking. 2-month-olds, forming memories, retaining them. So the question isn't whether babies can remember. They obviously can. The question is, where did those memories go? In 2025, a team at Yale did something no one had done before. They put awake, alert infants inside an fMRI machine and watched their brains form memories in real time. Led by neuroscientist Nicholas Turk-Brown and researcher Tristan Yates, the study found that babies as young as 12 months old showed clear hippocampal activity during encoding, the same brain signature adults show when they're locking in a new memory. The hippocampus, the brain's memory headquarters, was online, it was working, it was writing. So if the hardware works and the memories are being formed, then something else must be happening. Something must be erasing them. And that something is, ironically, the very process that's building the brain in the first place. Between birth and age 2, the human hippocampus undergoes explosive neurogenesis, the rapid birth of new neurons. Thousands upon thousands of fresh brain cells flooding into memory circuits every day. This sounds like a good thing. More neurons, more brain power, right? Not exactly. In 2012, neuroscientists Sheena Jocelyn and Paul Franklin at the Hospital for Sick Children in Toronto proposed something counterintuitive. All those new neurons weren't just building new connections, they were overwriting old ones. Think of it like this. Imagine you wrote a journal entry on a whiteboard. Now imagine someone is constantly erasing parts of the whiteboard to make room for new writing. The board is getting fuller, smarter, more complex. But your original entry? It's gone. Jocelyn and Franklin didn't just theorize, they tested it. When their team artificially reduced neurogenesis in infant mice, slowing down the production of new neurons, something remarkable happened. The mice kept their infant memories. They remembered things they'd learned as pups, and when they did the reverse, boosting neurogenesis in adult mice, the adults started forgetting. The same mechanism that makes a young brain flexible and powerful is the mechanism that makes it forget. Your brain chose growth over memory, plasticity over permanence. It wasn't a malfunction, it was a trade-off. But neurogenesis isn't the whole story, because even after the neuron flood slows down around age 2, memories are still fragile for years. The blackout fades, but it doesn't end cleanly. Memories between ages 3 and 7 are patchy, fragmented, unreliable. There's a second lock on the door, and it's not about neurons, it's about architecture. The prefrontal cortex, the part of the brain that organizes experiences into narratives, that gives memories context and sequence, doesn't finish developing until well into childhood. And there's a third factor. To form autobiographical memory, the kind where you're the main character, you need a sense of self, the ability to understand that you are a separate person moving through time. That doesn't emerge until roughly 18 to 24 months of age. So it's a triple lock. The neurons are overwriting, the filing system isn't built yet, and the main character hasn't shown up. Now here's where it gets genuinely strange. There's growing evidence that your infant memories aren't destroyed. They're locked. In experiments with mice, researchers used a technique called optogenetics, essentially using light to activate specific neurons, and they were able to reactivate memories from infancy that the mice had apparently forgotten completely. The memories came back. The physical traces of a memory in the brain were still there. The neurons that originally encoded the experience were still present. The memory hadn't been erased. The key to access it had been lost. Now, we can't do this in humans, not yet. And some neuroscientists argue that even if the engrams persist, they may have degraded beyond meaningful recovery. But the implication is extraordinary. Somewhere in your brain, there might be a trace of your mother's face, the very first time you saw it. You just can't reach it. And maybe that's the real answer. Maybe the question was never, why can't you remember being a baby? Maybe it's, why would your brain choose to forget? And the answer is, because remembering everything would have been catastrophic. A brain trying to preserve every sensation from infancy, while simultaneously rewiring itself for language, motor skills, social behavior, and abstract thought would collapse under its own weight. Rats, monkeys, humans. Every mammal on Earth goes through this same amnesia. It's not a bug in evolution. It's not a flaw. It's the cost of building a brain powerful enough to remember everything that comes after. Your brain didn't fail you. It sacrificed your past to give you a future. So the next time someone asks you what your earliest memory is, and you reach back, straining, grasping for some blurry fragment from when you were 3 or 4, remember this. That fragment survived a neurological onslaught. It made it through a flood of new neurons, an unfinished filing system, and a brain that didn't yet know who you were. The fact that you have any early memories at all is extraordinary. And somewhere underneath, deeper than you can reach, there's more. First light, first sound, first touch. Still there, still yours, just out of reach.